Hello, everyone. Welcome to the last module of AI Product Management Specialization. This project is around human factors in AI, and what I have chosen today is for the industry aerospace. I'm Sandhya Bhatt from SAP. Um, Right. With the problem statement, what we have today is predict maintenance requirements for aerospace engines to prevent unexpected failures and optimize the maintenance schedules. There is always this problem in aerospace where we need to have the predictive maintenance requirements so that we have a optimized maintenance schedule every time. Why is this an opportunity for an ML case? As explained earlier as well, this is a high impact case. Predictive maintenance can reduce the downtime, improve safety, and also cost for the aerospace industry. It's also feasible because data on engine performance and the historic data is often available and making it feasible to train the predictive models. Action why actionability, it's the early detection of the maintenance needs can also allow us for proactive maintenance, thereby having an optimized maintenance schedule as well. So when we dig down a bit more into the task analysis with the design thinking mindset, the user here is a maintenance engineer or a technician from an airline operations department. The task here is carried out by them to predict the potential failures or maintenance needs for aircraft engines based on the data collected from the sensors and also with some of the historical maintenance records available. The primary goal of the maintenance engineer is also to enable proactive maintenance and scheduling to minimize unplanned downtime, which can happen very much. So, trigger here, example case here is a real time alert. Let's take it like a real time alert. The system detects anomalies or predicts potential issues with an aircraft engine. The action item which comes to the maintenance engineer is a notification to maintenance engineer to engage the system for detailed diagnostics. The app which I've considered here is also called predictive maintenance system for aircraft engines. At this point of time, there's a decision which needs to be taken, not by the AI system here, but humans, like a maintenance engineer who decides on appropriate course of action based on the flight operations available, based on the resources available, like are the spare parts available, are the maintenance crew enough for me to carry out this action, what I'm thinking. So, at this point of time, the decision is made and an action is taken, alert review and verification. Um, there is a point of decision here again to determine the potential cause based on the system diagnostics and also the sensor data and the historical data which the maintenance engineer carries out. At the point of action, he also implements the appropriate maintenance action, whether it is an immediate action, a part replacement, or adjusting operational parameters. So at different points of time, there is a AI and a human interaction which happens to take optimized decision for for maintenance. Uh, and then we have the feedback, which also the maintenance engineers has have to take care. He will have to monitor the effectiveness of the action taken and adjust based on ongoing system feedback as well, which is also helpful for the data analysis of the entire engine or the fleet for that matter. With the task analysis, I would like to now dig down into the user experience design. I've taken here on the right hand side an example dashboard only. This is for the fuel mileage deviation, but it would be almost similar kinds also for the real time alert, which we have taken as an example. The UI system of the dashboard displays various metrics like, the temperature, vibration levels, pressure, everything of an engine. The maintenance engineers have to interact with the system in the real-time data visualizations, checking the maintenance alerts at regular intervals, setting thresholds, if possible, at different intervals to check and have a predefined limit so that you don't have to go till the end of the limit for any maintenance action to be taken. And also he can access the historical data via some reports, and also the past performance of the engine. With these two in mind, we could also look into some of the privacy considerations which are also taken from the data point of view. Here it is the security measures to implement the robust data security to protect sensitive engine performance data, which the company or the airlines themselves have to maintain, and also can use an encrypted data for transmission and storage, to have a regular security audits. Data privacy is also regulated to GDPR, CCPA in cases of in cases of if there are flight tickets, for example. But here, since we have taken into consideration engine performance, we may not go up till GDPR, but there would be some security data privacy for the engine itself from its origin, or from the country of its manufacturer. So the collection, processing, and the storage of data is also as important as well, and where the use of AI data is managed ethically. When we say ethically, there is also something called ethical consideration. There are potential sources of bias as well when we get the data, and we have to be very considerate and make a decision around a historical, there can be an historical bias, historical maintenance practices maintained from certain demographies or even certain types of aircrafts is also possible. There can be also algorithmic bias, which has been introduced in the past, and we would have to go check back on the data and make some informed decisions. Um, to ensure protection and recommendations, and to prioritize safety, operational efficiency, and well-being of the passengers as well, there is also the ethical usage of this data around three components, which is fairness, accountability, and transparency. The training data includes diverse range of engine types, operational conditions, and maintenance histories as well, which is fair enough to consider why is this engine giving us a problem, for example. And accountability to maintain the records of the different model versions, updates, and the performance metrics. The traceability allows for auditing and understanding changes in the model behavior over a period of time. So when for this problem, if there is a trigger, then I can go back and check the model versions or the performance metrics which has been before, and also maintain this new record into the system as well. Transparency, design the dashboard interface to be intuitive, so that the maintenance engineers can talk to the system to understand the clear visualization on why the data inputs or the model inputs, and also the reasoning behind the maintenance recommendations. With this, the maintenance engineers can really go and perform and make some informed decisions with the help of AI here to give us some optimized maintenance schedules, and thereby increasing the operational efficiency. With this, my today's project presentation is done. Thank you very much.